topics. So we're hitting some of the big review things. I have 2 more topics, and then we'll be ready for our first test.
Okay.
So we will spend a few days on this topic. There's a lot in here. It's looking like we probably won't be ready for a test next week. It'll be the week after.
Wait, this is still our review, right?
Yes. So, transformations. What do you remember?
Up.
Oh, okay, I do. Okay.
Plus is up.
All right, so if it's on the outside, it's Y. So if plus C on the end moves it up. A minus C on the end moves it.
Down.
All right, what if I put it on the inside, so it's attached to the X?
Left.
Slow.
It does the
So
opposite.
it does the opposite if it's on the inside. So subtracting.
Yeah. And it switches it.
What does this C on the outside?
Stretch.
Hmm?
Stretch on the line.
Right. Vertical.
You have a pencil.
I'm going to say stretch or shrink. How would you know which one? If it's bigger than 1, it stretches. If it's smaller than 1, it would shrink. If you like multiply by a half, it's saying take your height times a half, so it would get smaller. Okay, if it's on the inside, so it's a horizontal. Stretch or shrink. All right. What does a negative do? Flips. So if it's a negative on the outside, it would flip over. So it's like saying you make your Y is negative, and so it flips it over the x-axis. Negative on the inside is making your x's negative, so it flips over the y-axis. All right, let's do it.
Let's do it.
There's a bunch of them here. Do you think we can draw these all in one graph?
No.
Probably not.
All in one.
Yeah.
Freak.
Let's try it.
Less work. Let's get the colors out.
Yes, colors. Oh. I gotta do my original one in black though. Okay. So, parent function. Y equals the square root of x. What does that look like? Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. I'm going to do that one dash. This is my parent function. So it is curved. Now let's go through the transformation. So you can draw these on multiple graphs if you need. What would this one do?
Down.
So the 2 is outside the square root, so I move each of these things down 2. Second one, the minus 2 under the radical, right 2. So it's back to the original. What about a negative square root of x? It's taking the whole thing, it's like making the y's negative, so it flips it over, it'd be x out. So, I said x and then I started doing y. Whoops.
Darn it.
Helps if I do what I said. If you aren't color coding these, make sure you label each of them on your graph. Okay. So what does the 2 do? The vertical stretch. It's essentially taking your y's times 2. So if I look at this original, I started with a y value of 0. 0 times 2 is still 0. This point had a y value of 1. 1 times 2 is 2. This point had a y value of 2. 2 times 2 is 4. So that vertical stretch just made my graph get taller. And one more. The square root of negative x. What does that do? So if I flip over y, this would stay. And these come over. It's a little bit quite quick. Is that one okay? Okay, so if I wanted to use transformations to get a graph, if I'm just looking at this, x squared, what's the graph of x squared look like? Quadratic. So I'm thinking about a parabola. But if it's written as x squared plus 6x plus 10, it's not obvious what my transformation would be. So if you remember, what we did is rewrote this. We had to complete the square in order to have it written so that we could use our transformations to graph it. Okay, so completing the square. We start out, we want to keep our x's together. I'm going to leave a little space. I'm just going to put this plus 10 outside. Now I can't change my problem. I'm just rewriting it. So in completing the square, you take your middle term, divide that by 2, and square it. So 6 divided by 2 is 3. 3 squared is 9. So if I add 9, what do I have to do to keep this equation balanced? Subtract 9. So I just had to come up with what number to put here. So what two numbers multiply 9 and add to 6? So I could write this as x plus 3 squared plus 1. Is that okay?
If you know people that are certainly well enrolled in a certain program, I can send them names and we'll pre-enroll them so that the time is quicker.
Okay.
So just send me names as you get them, or send them over. Carrie has also handed out several packets, so some kids might already have them.
Okay, thank you.
Thanks.
Alright. So, what would my transformations be now?
Left 3 of 1.
3 of 1. Let's draw the graph. So you know I require a minimum of 3 exact points, but you could always do more. So the original, 0 squared is 0, 1 squared is 1, 2 squared is 4, negative 1 squared is 1, negative 2 squared is 4, so that's my parent function. Point left and up. Okay. So negative 4 divided by 2 is negative 2. Squared is positive 4. So if you add a 4 on the inside, you have to subtract 4 on the outside to keep it balanced. Then multiply positive 4 and add to negative 4. That would be negative 2 and negative 2. So x minus 2 squared minus 25. So if we take our original parabola, 0, 0, 1, 1, negative 1, 1, and we have to move it right 2 and down 25.
Oh, I didn't do that. I moved it up 25.
Yeah, I did that too.
Why did I do that?
Is this okay? Let's try another one. Maybe not the graphing, just the complete square, making sure we can. How is this one different?
I'm going to go 2.
There's a 2. Okay. So here's what we're going to do. We need the x's together. In order to complete the square, this needs to be 1. So I'm going to factor a 2 out of there. That leaves us with x squared minus 3/2 x. Now, does everyone agree that if I multiply this out, I still have my original problem?
Oh.
No. Yeah.
Alright, so now, completing the square. Wait. Middle term divided by 2 squared. Alright, so let's practice not using a calculator. This is like 2 over 1. To divide fractions, you flip and multiply.
Oops.
3 over 4, negative.
It's left.
So if you square that, what's negative 3 times negative 3?
9. Oh, that's it.
And 4 times 4. 16. Okay, now, careful. If I work this out right now, if I distribute it, we have 2x squared minus 3x plus 9 over 8. If I multiply my 2 out. So what do I need to subtract here?
Minus 9 over 16. 8.
9
Where's the
over
8?
Oh.
Okay.
I thought I could slide by without realizing.
If you multiply it, that's 2x squared minus 3x. That would be 18 over 16 or 9 over 8.
Oh, so you just simplify.
Mm-hmm.
Oh, yeah, I got that.
Okay. So, we have 2. This would go to x minus 3/4 squared. It's always that number before you squared it. 1 is like 8 over 8, so negative 8 over 8 minus 9 over 8. It's negative 17 over 8. I just wanted to practice the completing square on that one.
Is it either like that on the text?
Could be.
Good. That's not pretty. You said you could get pretty numbers on the test.
I did it without a calculator.
Aren't pretty. You did.
Alright, let's try another transformation. What are you sighing about?
No, I remember this one.
Oh, I thought you.
No, that's not, I remember this one.
Okay. So, parent function is absolute value, the v. Okay. So, absolute value is 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2. Alright, what will the negative do? Flip over the x. What does the plus 1 do? So I'm going to flip it and go to the left. That took a little while to do this. Alright. We are going to skip this example.
Oh.
I want to go to this
Thought we were done.
More boxes to go.
one. See, we're flying now.
Almost out of single digits.
These boxes.
Where the boxes go?
Your grass.
I don't know. It's just like that is.
You just want this.
I want the domain of f times g
So. Okay.
if f of x is 1 over x and g of x is the square root of x minus 1. Makes perfect sense, right?
Sure.
So f times g. If I multiply those, this is really just over 1, so you multiply the tops. You get the square root of x minus 1 over x. When we talked about domains, I told you a couple rules. If you have a radical, what has to be true about the thing under the radical?
That's positive.
So x minus 1 has to be greater than or equal to 0, which means x has to be greater than or equal to 1. If you have a fraction, what has to be true?
11 cannot.
Denominator can't equal 0.
Okay, so in that case, my denominator is just x, so x can't be 0. So I have to put these two together. It has to be bigger than 1, and it can't be 0. If it's bigger than 1, does it equal 0? So my domain is just everything from 1 to infinity. You can take any number, 1 or larger, plug it into that problem, and get an answer. Alright, B, f plus g. So if I added those, I get square root of x plus the square root of 2 minus x. I have two radicals, so we have to look at each of them. So the first one, just an x underneath, so x has to be greater than or equal to 0. Second one, 2 minus x has to be greater than or equal to 0. If I add over my x, that means 2 is greater than or equal to x, or another way of saying that is x is less than or equal to 2. How do I put those together?
0 to 2.
Yeah. Think about your number line. I'm saying it has to be bigger than 0 and smaller than 2. So the only thing that worked for both of them was in between the 0 and the 2. F divided by g. So f is x squared. G is x minus 1. So what's the domain of this?
X minus 1 can't equal 0.
So x can't equal 1. So I would write that as negative infinity to 1, union 1 to infinity. Alright. I better stop there. Yes.
Is the one thing in the bracket?
No, because bracket means equal to, and we want it to not be